Welcome everyone who are here. Nice to have your enthusiasts here. So this webinar is as the second follow-up of the training course we did in February and March for the Zero Waste Ambassadors for Community Leaders in Africa. This was the topic picked up by you. So the biowaste treatment for low-income communities was second most popular one. We have three speakers today. We have Enzo, who is from Scuola Agraria del Parco di Monza, which is a very fancy institute in Italy with a very long name. Enzo is also scientific coordinator for Zero Waste Europe, and I would even say a big fan of biowaste and composting. So he will kick off this webinar with his insights. We have Matthew Hayden from Tanzania, from Recycler, and we'll talk more about specifically of black soldier fly and maggot farming and how you can use compost for this exciting opportunity. And then we have David from Type and Waste Management based in Kenya, who will also talk about the actual example in African context of how to market and sell your compost. So it's going to be hopefully quite exciting and digging deep in a pun intended way of what to do with biowaste. Simple rules, just that write the questions in the chat. You can already write them during the presentation, like if you don't want them to get if you don't want to forget them. So I will take them. Then after each presentation, we will have questions. And then later on, once the presentations are finished, we can have like a general discussion. And we are also recording this. This video will be later on also public in YouTube. So this is just for you to know if you don't want to have your face shown or something like this, that it will go on YouTube. But on this side, I'm actually stopping my sharing, and I'm giving. Just making sure that Enzo can share. And yeah, so Enzo, floor is yours. Take it away.
Thank you so much, Kadri. I'm excited to start this webinar. And also very, very happy to meet so many friends and nice people we cross paths with during many training programs. So let me share my slides. Here we are. Okay. So, organics are important, but I do not have to convince you by now. It's the largest contributor to the total composition of domestic waste or municipal waste, household waste, call it as you like it. But also its importance is not only related to the quantitative angle, because it's fundamental if we want to achieve the highest material recovery rates. And this is why we always put it on top of local zero waste programs and schemes. This is what we ask from the zero waste committee, the local communities. But there's also an operational angle, because once we are effective in capturing the organics, we may minimize the percentage of organics and residual waste. And so we may sharply reduce the collection frequency for residual waste, which is important. First of all, because it saves you money. And secondly, it exerts a further driving effect towards better separation also of the dry recyclables. Glass, plastics, metals, wood, whatever. But also, this is not only related to waste management, because when discussing composting the organics, we have got an end product. And unlike other recycling schemes, which take our materials elsewhere, subject to globalization and something like that, this may be done fully locally. So we have got something that may be beneficial to our soils. And so it cross paths with many angles of environmental sustainability. So to help you build your composting agenda and to sound more convincing with your policymakers and decision makers, I inserted this slide which recaps quite a few sectoral policies which are picking on the importance of recovering organics. The climate policy, because if we store carbon in soils, they call it carbon sequestration. We will have less carbon as carbon dioxide in the atmosphere. We may restore fertility and we may fight desertification. There is a United Nations Convention to combat desertification, which gave birth to the Paris Agreement signed back in 1994. And it also draws attention to the importance of restoring organic fertility in soils. We can make our soils and agriculture more resilient against extreme events such as floods, landslides. We may fight eutrophication, which happens when we use mineral nitrogen fertilizers and so on and so forth. You may be happy to know, this is not Africa, but this may help you reinforce, consolidate your set of arguments, that Europe made separate collection of the organics an obligation as of January the 1st, 2024. So the obligation is right around the corner, but it was largely anticipated by similar obligations in many countries, Germany, Netherlands, Italy, Romania by the end of this year, and so on and so forth. Basic first, what are the key principles for a bio-waste strategy? We have to keep in mind the cascading principle. You may remember we discussed the cascading principle when discussing the basics of zero waste. Reduction is the final goal. Recycling and composting, anyway, are the low-hanging fruits, because we have got bio-waste which is produced every day, and so we may capture it and send it to composting. We have to engage, of course, with the local communities, not only the households, to do separate collection by the households, but also with businesses. Consider the large producers, restaurants, canteens, greengrocers, supermarkets, whatever, and the waste handlers, in order to convince them and have them on board and fine-tune their system according as appropriate, according to our needs. There is no solution, one solution fits all. We have to adapt to the local context. I've been working on bio-waste strategies in very diversified situations, from the United States to Cambodia. And of course, I cannot propose the very same solutions everywhere. And also remember, while we target perfection, we may live with transitional imperfections. So be happy, albeit never satisfied, as we said during the webinar. We may start considering also solutions that are less than perfect, and then we will improve them in time. You may remember the cascading principle. Our order of priorities when we consider bio-waste is feed the humans. This also matches one of the sustainable development goals, which is reducing by 50% food wastage by 2030. We may then consider feeding the animals, as long as it's still suitable for animal consumption, and then we may consider feeding the soils. And this is what we are discussing today by means of composting, but I will also dwell, albeit very briefly, on anaerobic digestion at the end of my presentation. Always consider, we say, waste is like water. It always flows the easiest way. We have to make it flow the easiest and the proper way. Easiest and most appropriate way have to overlap each other. So we have to work on such tools as those tools that make the system proper, tidy, user-friendly, so they maximize participation, and also on collection frequency. In particular, let's consider a higher collection frequency for bio-waste than the collection frequency for mixed garbage. Otherwise, there will be nothing boosting the participation of people in separation of the organics, as you may easily understand. When it comes to tools, well, in the global north, it's very common to find such tools as the compostable bags. These are certified compostable. There are relevant labeling and certification schemes to certify they are compostable. But you may equally consider paper bags, or you may consider also newsprint. You can put some newsprint as a liner within your buckets, so it absorbs excess water, doesn't cause any mud, any yuck, any nuisance for the households. But then we may consider, you know, starting from scratch. These are from India. You may consider still the buckets, but these are not the standardized buckets as you may expect in many cities. Not only in the global north, but maybe also in larger cities in Africa, but also in the rural settings. You may consider, you know, makeshift buckets, well, normal buckets, or even wheelbarrows. These are wheelbarrows which are being used for separate collection in Zanzibar, not far from where many of you are sited. And this is an international cooperation program between Zanzibar and an Indian cooperation agency. And they use wheelbarrows in order to deliver their organics, or also during other days, plastics, to the collection points. you have seen that in previous slides, I was keeping you focused on specific system to collect food waste. It was not commingled with garden waste. Garden waste is another important chunk of bio-waste, of organics, but the food waste and garden waste have got sharply different properties. Garden waste is not much fermentable, but it's very bulky. Whereas food scraps are very, very fermentable, and so we should be collecting them quite frequently, and they're not bulky. They take up a very small volume. So this might be a first reason to have dedicated collection rounds for food scraps on the one hand and for garden waste on the other hand. Also because when you have got garden waste, you have got gardens in which you may promote some individual home composting. So if you make it too easy to deliver their garden waste, there will be no participation at all in home composting programs. But also the destination, the so-called soft organic waste, which is food scraps, may go also to dedicated systems such as individual biodigesters because they are highly fermentable, or partly be mixed up with hard organic waste, twigs, leaves, grass, bamboo, straws, whatever, in composting pits. So this is another reason why I would recommend having dedicated collection rounds which are kept separated for food scraps on the one hand and garden waste on the other hand. Also, you may optimize your fleet of vehicles because while garden waste is very, very bulky, just like plastics, and so they may benefit from the use of large packer trucks, compactors. For food scraps in large cities where you may diversify the fleet of vehicles, you may consider much cheaper small open lorries with no compaction. They're very, very cheap, and so they keep the cost of collection comparatively low. And this is why we may increase the collection frequency for the food scraps. And as you can see, the food scraps in the compostable bags in this picture on your right-hand side makes 100% of the volume. There are no garden waste in that. You may say, well, this may work in rural settings, but what about the large cities? Be confident that this is already happening in quite a few cities. For the moment in the global north, San Francisco was the first one. San Francisco totals slightly less than 1 million inhabitants. Milan, where I'm based, is for the moment the largest city in Europe to collect food scraps from 100% of the population. It's 1.4 million people, and then there are 800,000 daily workers, commuters, getting into the city and producing food waste in the city, at least for lunch, then 11 million visitors. And the result of implementing the curbside system, the separate collection system for organics, was they went up to 63% separate collection rate, more than 100 kilograms food scraps collected from the city per inhabitant and per year. So it is a very large chunk of municipal solid waste, and it is minimizing disposal. To make you further confident, if you say, well, this may work in Europe, this may work in the global north, but not elsewhere, these are the ethnic groups which have been registered in Milan. And as you can see, there are Egyptians, there are Moroccans, there are Bengali, there are people from all over the world, and they do separate collection just as the Italians. So this means it is the organizational context that triggers the proper behavior by people. So be confident in this respect. Now, the second and last part of my presentation will be about processing the organics, just giving you a very quick overview, starting with stupid things. This is what my professors at university were telling me. We always start with stupid things in order to give the basics. Composting is a natural process. It may need, though, to be controlled and engineered to a larger or a smaller extent. Of course, the smaller extent is in individual composting, whereas largest engineering comes with industrial composting in centralized sites, because we needed to make it faster, we needed to secure the quality of the outputs, and we have to minimize or avoid these amenities altogether. Odors, greenhouse gases, pest attraction, flies, rodents, whatever. Of course, in a small composting site, in individual composting, this is not of big importance. But if you have got a larger centralized composting facility, you needed to give guarantees to the neighborhood, of course. We do not have to reinvent the wheel. There's a very long history and tradition in composting in many different approaches around the world. And also we say small is beautiful because we wanted to keep as close as possible to the proximity principle. But is it always like that? Follow me. When we have to move elsewhere, we normally consider, well, we may consider a car or we may consider a train, depending on where we have to go. The car is smaller than a train, but the train is more environmentally friendly than a car. So it depends on situation, it depends on the organizational context. We actually, the key message is we actually need all of such approaches, from individual composting to community composting to decentralized professional to centralized industrial composting. And so you may consider all the types also with makeshift containers such as pots, buckets, wooden boxes, concrete pits, whatever. The basic rule is that we have got the different types of materials we already mentioned when we were discussing the collection, the basics of collection. We have got the slowly decaying materials, the bulky materials, bamboo, husk, straws, shrubs, tree trimmings, wood chips, and so on and so forth. And then we have got food scraps, bespoke food scrap, properly said food scraps, which are highly putrescible. They are rich in nitrogen, they degrade fast. It is vegetables, cooked food waste. Of course, sewage sludge is not for home composting, but for industrial composting, meat and fish. And the important is to have them mixed because we need both. The bulky materials make the heap porous, and so they let oxygen get inside the heap in order to let the microbes carry on the aerobic process. But since we do not have blenders in home composting, the easiest way is to make layers. Make layers, bulky, putrescible, bulky, putrescible, bulky and putrescible. You can also consider very easy ways to do a do-it-yourself composting silo. This is something we have taught hundreds of thousands of people to make their own do-it-yourself composting silo with a mesh wire and a fleece, as you can see on your right-hand side. The most important, as you can see here, at the bottom, we always put a first layer of very bulky material, because this is important in order to get rid of excess water. And this may be done also with a wooden pallet. If you have got wooden pallets, consider that, and then build your heap or put your silo on top of that. Or you may consider straw, bamboo, twigs, leaves, whatever, in order to drain excess water out. Because if you don't drain it out, it will make the material soggy at the foot of the composting heap, and this will divert the process towards anaerobic. So it means bad odors, not a proper degradation of materials, and so on and so forth. So with that in mind, you can give freedom to your fantasy. These are the tire tower composting systems or the jeans composting system. And you have got, yeah, the drainage layer, and then they make layers here. Bulky and putrescible, bulky and putrescible. This is, of course, a fancy way of doing composting in order to attract interest and curiosity by people. This is from the Philippines. I inserted also a slide on the basics and troubleshooting. Of course, we will give you the slides, so you will have to the basics to remember when you will have to, when you want to start your own composting program. Moving a step higher, you may consider community composting. Maybe people do not have any private space, but they can get together in a common yard and make some community composting systems, which are pretty much widespread across the world, in the global north, in the south, and so in Indonesia, in the parks, in Malaysia. This is from Switzerland. This is Zurich, which is the most populated city in Switzerland. They do not have any centralized composting site. They have got 600 community composting sites. Or small-scale centralized composting. This is already professional composting. It may be done with windrowing. These are windrows. This is the technical wording for that. And here you can see a windrow turner. Of course, you can use your shovels. You can use your plows in order to turn your windrows, but when the tonnage becomes higher, you may consider machinery, equipment in order to do that on your behalf. Or you may consider forced aeration in order to supply the needed oxygen to the windrows. This is a tactical approach which may be done at small scale or at a bigger scale. Of course, I'm guiding you through also through the more high-tech solutions, because there may be some granting programs, international cooperation programs, or loans coming from international cooperation agencies, subsidy programs. And that being the case, you may consider also installing your own initiative and servicing your own city, your own district, your own neighborhoods. The tactical approach may be based on biocontainers or aerated static piles with a fleece covering the biowaste. You may start with small quantities, and then in parallel with the enlargement of the separate collection system, you may add more modules, more biocontainers, or more aerated static piles. So it's a particularly wise tactical approach. You may also consider involving farmers. You see a question mark here. Shall we involve farmers? Yes, indeed. This is an exclamation mark. Always consider involving farmers. This is from a particularly evolutive national situation on composting. This is Austria, which is probably the country with the highest biowaste capture in the world, because there is an obligation on each individual to either do home composting or to separate the organics. And they made deals, they made agreements with the local farmers. They told them, you have got the slabs, you have got machinery, you have got interest in using the end product. So instead of building our own composting sites, we as a community will give you the biowaste and you will process it on our behalf, and we will reward you. This may be another approach. Or centralized industrial composting. You may have many different technologies here as well. This is dynamic-based IPS system or biocontainers, bioboxes. Whenever they ask you, what is the best system for composting? Always reply, it depends. It depends on the local context, how big is your site, whether you are seeking more automation or more labor-intensive schemes, whether you may face high capital expenditures or lower capital expenditures, and so on and so forth. Anyway, when you have got very large composting sites, normally you have to consider also odor treatment. So treating exhaust air in order to have odorless air released into the neighborhood. And the best way is a very natural system, which is a biofilter. We may discuss it during the follow-up discussion. So now, the last slide is on anaerobic digestion. Anaerobic digestion, well, there are pros and cons, because, you know, I always see there are fans of anaerobic digestion and they say all the biowaste processing sites, they should be anaerobic digesters. And then on the other hand, David is asking for the remote control on my screen. I have to reject for the moment. I'm sorry. Anaerobic digestion. Then on the other side, David, don't click on requesting the remote control of the screen. Thanks. On the other side, there are the fans of just composting. Let's consider only composting. Well, depending on situation, either one makes sense, because anaerobic digestion is more performing from the environmental standpoint in that it turns biogenic carbon into a renewable fuel. It's fully renewable. It's biomethane, and it may replace fossil fuels. Instead of natural gas, oil, coal, whatever, we may use biomethane for our kitchen fires, for our trucks, cars, buses, whatever. There are subsidy programs in many parts of the world which are promoting these in order to meet the renewable energy obligations. It's also less dependent on the availability of the bulking agents, garden waste. We said garden waste is badly needed when we consider composting, but it's not so needed when we consider anaerobic digestion. So if you are living in a city with a high production of food waste and a low production of garden waste, you may consider anaerobic digestion. But on the other hand, there is a flip side. No meal is for free, of course. You have to consider unit investment costs, which are typically higher than composting. So subsidy programs may be important in order to make the economics work in this respect. There may be also international subsidy programs or the clean development mechanisms, which are funding initiatives in the global south in this respect. And it is also typically more affected by these economies of scale. So if you want to start small, consider composting. If you convince a big city, you may also consider anaerobization. We did a guidance, a decision-making tree at the Zero Waste International Alliance on choosing between composting and anaerobization. So it guides you through all the factors to consider whether it's better to opt for composting or to opt for anaerobization in any given specific context. You will find in the slide, you can see it at the bottom of this slide, the link to download it free of charge. So read on, compost on, and be happy. Thank you for your attention.
Thank you, Enzo. So we can take a couple of questions now, if we have any. So I can even say that since we're not so many, you can either unmute yourself or type the question in the chat, and then I can take it. So if there's anyone wanting to ask something, go ahead. I can also put, while you're maybe thinking your questions, I can put in the chat a while ago. We made a simple document with Let's Do It Foundation on basics on composting and how to deal with bio-waste. So you can also get this as a basic reading, but other links will be sent to you with the presentation, with Enzo's presentation. So do we have any questions at the moment to Enzo?
No question means they are fully convinced already.
I could just give a comment that I remember once a farmer taught me how to make compost, and she said, you know, it's like making lasagna. You just make the layers.
Right, make layers, yeah. And nice, the Italian lasagna
So it's like making lasagna
as a proxy for composting. Yeah, indeed.
Yeah. Okay, so while you're maybe thinking are your questions, you can also have them later on. So then I would invite Matthew for his presentation on what he's doing in Tanzania and focusing on maggot farming and bugs and insects. So go ahead.
All right, guys, thank you very much. I'm just trying to share my screen. There we go. I hope everyone can see. I am the founder of The Recycler and a spin-off company called Biowaste. I'm going to speak just specifically about Biowaste and insect farming for Biowaste. Essentially, insect-derived feed is what we're after. 40 to 60% of the waste in developing countries is organic. In Tanzania, there have been many different, studies on it, and it says around 40 to 60%. At the same time, chicken feed and fish feed for aquaculture is very expensive and it has lots of issues, which I'll address. So we use what is called the black soldier fly. This is native to East Africa, not endemic, but it's all over East Africa and in most of the world. And it is an amazing eater and does not carry diseases. The two issues that we're addressing is the methane release from organic waste. So when you take organic waste to the landfill site, of course, it releases methane, CH4, and this is much worse than carbon dioxide, I'm sure as many of you know, but it's specifically worse in the sense that it has 80 times the warming power of carbon dioxide in the first 20 years. So that is important for us now because we're very worried about warming. Overall, it's around 28 times more powerful. So when you have in Tanzania and in Kenya, you have lots of the organic waste going to the landfill. There's no, proper management of it in the sense that it is releasing large amounts of methane. The other issue is protein for animals. So basically, the main sets of protein that we use to feed animals is soy and fish meal. On the left, you can see a soy plantation next to the Amazon rainforest. It's constantly known for knocking out you know, deforestation and increasing that. And most of the soy is not fed to humans, it's fed to animals. Around 70% of soy is just fed to animals. And these are at unsustainable rates. And essentially, you know, it takes about 2 times as much soy to make 2 kilograms to make 1 kilogram of chicken. When it comes to, you know, cows, it's up to 7 times. The other protein is fish meal. I'm sure many of people have seen the recent Seaspiracy or other documentaries about the current state of our oceans right now. The reality is that we have overexploited vast areas of it. We've seen, you know, large fish stocks continually to be depleted every year. So when we're using fish meal, we're taking out fish to feed fish. So we're looking at more interesting ways to make protein. So at BioBoo, we use the insects. We take in the food waste mostly from the markets, and we use our insects to eat it. It turns it into essentially food for either fish or chickens, and compost for the farmers. And you can see on the land-based area, on the greenhouse emissions, on water usage, all of these areas are worse.
Sorry, I muted you.
Oops, sorry.
Yeah, go ahead.
Sorry, I've gone ahead here. Okay. Can I get the remote? I think that I'm not able to.
Well, did David request that again? Just
no, okay, we're fine now. Okay, I'll continue. Good. Yeah, no worries. So at BioBoo, we have 3 different models. The first is the large-scale factory model. We also do these household bins and a community design. So the first model is the large-scale factory model. We have 2 large-scale factories, one in Dar es Salaam and the other one in Kenya, in Mombasa, Kenya. And this is basically taking food waste from large-scale hotels and markets, places where we can congregate and control how clean the waste is very easily. So we take that waste in. This is a video. I don't know how it's going to come across, but you can see the waste goes into our facility where it is shredded. And then, so we make sure it's clean at the source. We shred the waste. And then in the next slide, you'll see that we use a mixer to add different types of it. And then we put it in these trays. So each tray has around 3 to 5 kilograms of waste. And then we pop in 10,000 larvae per tray. These larvae eat through that waste in about 7 days. And then we separate the larvae. Some of it goes back to the breeding. So this is the ones that go back to the breeding. And the rest we make into high protein feed. And then also the other byproduct is compost. So it looks like this, where we're feeding, you know, thousands and thousands of larvae in a very large tray system. And then the products that we get out here are the dried feed and the compost. The compost has around 3% nitrogen, about 2.5% potassium, and about 2.7% phosphorus. So it's a very, very good compost. And it's very fine because we shred the input material. The larva, in this we dry it in a dehydration method. And then we even can process it further, where we can separate the oil out of it and make a nice fine 54% protein meal, which we have made into dog food and even to floating fish pellets. And the oil also we've used to add back into these different methods. Our current expansion plans are to keep putting up these large-scale factories. We're going to follow the weather and the waste. So we're looking at new locations now where we can put new factories up, where there's a lot of available organic waste that's easily accessible, and where the weather is right for our insect. It likes to breed around 27 degrees Celsius. So rather than adding lots of energy and weather and heat and sunlight, we'll just go to the locations where that makes the most sense. The second part of it is the household bins. So every time people see our insect project, they say, well, we want to do this. We have waste at home. these areas. And most people in Tanzania, they keep chickens. They're farmers in some way. 60% of households have some sort of small scale livestock they're working with. So we said, okay, well, what can we do for household levels to encourage people to separate their waste at source? So we designed a lot of different types of bins where essentially, because the larva is everywhere, if you leave waste anywhere where the insect can come into it, the fly will find it within 6 days. They'll lay eggs, and you'll have an insect bin. And this also reduces house flies, which is a different type of fly. We're using the black soldier fly. The house flies are the ones that eat and can spread diseases. When our flies, they don't actually spread diseases, and so you actually can reduce house flies by up to 90% in different areas. We settled on this design, which is allows the flies to fly in, eat the waste, and then the larvae crawl out into that small bin. We've sold about 200 of these bins. We're trying to keep them as cheap as possible, so any Tanzanian can afford it very easily and can use it. The main criticism we've got on these bins is that they're not big enough. They want to be able to produce more larvae to feed more of their chickens. So we try to make larger size bins. We've had a lot of different designs for that. The problem is the bigger you go, the more expensive it gets when you have to add scrap, metal into it and welding and all of this. So now we're developing essentially a community size bin. So when you sell it to one household, the costs get expensive. But eventually you can make a community size bin that can service 100 households, where the community is incentivized to separate their waste because they get the larva out of it and they see the benefit of the larva through the chickens having more eggs or growing faster. So we're developing that right now, and we hope that we're putting 6 community bins and 6 communities in Tanzania. And if it works well, it's something that we can expand throughout the regions. The other project we're also doing is a large-scale composting. It was nice to hear Enzo's presentation. We've set up a large-scale windrow ventilating compost system with CO2 funds from the city of Hamburg, using those, basically where the city of Hamburg is producing carbon credits, and instead of buying them online, they've decided to build this massive facility to offset their carbon in Europe, and they've decided to build it in their sister city of Dar es Salaam. So it's great to see, kind of co-financing schemes that are working. And so we just started operating this about 1 month ago, just opening it now. And the input capacity is 50 tons per day. Right now we're doing about 14 tons a day. And that 50 tons can produce on average around 15 tons of compost. We'll know in about 2 months. And you can see that the windrow composter here is turning the waste, and yeah, it's a very interesting project for us, and to add along with a different type of compost that we're selling from our insect project. Yeah, that's about it from me. If you guys want to see more about what we're doing, you can follow us on Instagram or Facebook. Thanks.
Thank you, Matt. That was super interesting. I see that Abraham also already commented in our chat that this is something that he's really interested in. So maybe you have guys some questions now you want to ask. So either write them in the chat, or since we're not so many, you can also unmute yourself and ask the question. So is there anyone who wants to ask something now?
Good morning. Good morning.
Yeah, hello.
My name is Derek. I'm joining in from Zambia, Lusaka.
Yeah, Derek, what's your question?
Yes, I wanted to find out in terms of the cost for the animal feed. The portion of the presentation. How much would that cost? And is the financing available? Thank you.
Thanks, Derek. Should I answer that one now, or do you want to take a few more?
You can answer it already, and then we can take a couple more.
So when we're for animal feed, we're competing on a percentage protein basis with soy or fish meal. So if we're selling to aquaculture, we're competing against mostly fish meal. If we're selling to chicken farmers, we're competing against soy. So the soy price fluctuates anywhere between $300 to $600 to $700 a ton, and it has slightly less protein than our insect finished meal. But basically, we have to be competitive. So nowhere will they buy our product of insect protein if it's not competitive with soy. Fish meal, on the other hand, it's significantly more expensive, around 1,200 or more per kilogram. So, you know, and ideally we try and sell to people who are replacing it with fish meal. Right now in Tanzania, we're selling it around $600 a ton, and we have more than enough. We can't even meet close to the amount of demand that we have. But of course, we want to seek higher prices across. We want to be selling it around $1,200 a ton, the 50% protein, 55% protein basis. So that's what we're aiming for, and it makes us more sustainable to do that. Regarding so when you make the finished feed, also you add additional costs, which makes it cheaper. That's not the price for the finished feed. That's just the price for the protein component of the finished feed. Regarding access for financing, we're working with carbon offset companies who are saying, look, we can maybe fund other expansions of your product with carbon credits. So we're in a deal like that now, but you know, these large scale processes, they're not cheap. You know, one of our factories costs as much as $700,000 and does about 20 tons of waste per day. So right now we're in the process of getting funding for more and more expansions, but that's after we prove that these ones are working well.
Okay, we have several questions now in the chat. First ones are more geographically based. So Abraham asking if they also work, they are found in West Africa. He's from Liberia. So how do they work there? Then we have a question of if you have already partners in Lesotho, and because people are also interested in that. So maybe you can just take those questions first, and then we have more questions for you.
Thanks. Yeah. So yeah, regarding Liberia, it's definitely going to be in Liberia. No chance. You just take your waste, put it in a bucket, you know, drill a small hole of it, and leave it outside for 2 weeks, and you'll have the larva. First, the housefly will arrive because the housefly, they lay eggs on top of the waste, and their eggs hatch very quickly. But as soon as the black soldier fly comes, it will get rid of all the houseflies. They eat them or they scare them away. So there's no more housefly. But you can have your own bin that you can make anywhere in Liberia, and I guarantee you'll have the large larva there in 2 weeks. So yes, they're definitely there. Regarding partnerships in Lesotho or other locations, Liberia, you know, right now, you know, we will partner with anyone if they're able to raise the funds. In the meantime, while we're looking to raise funds for different expansions, then, you know, we're not looking for partners for that because we will be raising the funds. But if you can raise the funds to build a plant in your location, we're very interested in working with you. Lesotho is a bit cold, but so it wouldn't be our first choice. But yeah, it's a possibility. Other questions, webinars and trainings.
Yeah.
So we don't do a lot of that. A lot of our large scale production methods have been 4.5 years of research and development. So we're not going to open the book on everything there. We need to grow our company and grow our possibilities. When it comes to community bins and to household bins, that's something that we will do as we implement these community bins. So we're happy to show everyone in the world that, and that's kind of our way of saying, you know, anyone can copy this and use it anywhere. It's not something that we're focused on as a private company to make money on. Regarding, I see another question about Yeah, a lot of questions.
How,
You
yeah.
go ahead, sorry.
Yeah, so the next questions are how much are each composting bin, and where do you have the community composting bins in Tanzania if you accept organic waste from households, and yes, how much do they cost? So
okay,
you can take
great.
that one.
So our household insect bin is 70,000 shillings, and it includes starter insects as well. It just helps the process go. So that's like about, I don't know, like $25 per bin. So that's the cost of that. For the community designs, we've selected 6 communities, 3 in Morogoro and 3 in Dar es Salaam, where we will implement those community designed locations. Those haven't been done yet. We're in the process of building those right now. Regarding organic waste from households, so we have large skips collecting from markets in Tegeta, if you're familiar with Tanzania, Tandale market, as well as Buguruni. So those are the largest markets in Tanzania where we collect for our composting site and also for our insect factory. So anyone, of course, could bring to those skips organic waste, and we'd be very happy to take it. We also sell a small compost bin, similar to some of the designs that Enzo shared. It's just like a blue bin with a bunch of holes in it. You can make it yourself. It's very simple. But if you're interested, you can contact us, and I can send you. And that's for all waste, not just food waste. It's also for the the trees and leaf waste that you have.
We also had a question from Enzo, which is rather for clarification. So is your carbon credit scheme from Clean Development Mechanism? So it's a question about funding in terms of, as I understand, so if it's part of this or also for people to sort of maybe start thinking of where they might get the funding themselves.
Yeah, so I don't know those schemes. The first scheme is basically for the composting plant. It was the city of Hamburg. So the city of Hamburg in Germany, I guess they were required to pay into to like a fund for all the carbon, based on the use of the municipalities, whether they fly or whatever. And so what they did is that specific fund, it was building up over a number of years. And then with that, they said, okay, what can we do? We can either buy carbon credits through whatever system that most will buy carbon credits, or we can decide to fund a project. And so they chose to, look, we'll fund a project in Tanzania for this. So they built this, I think it's a $4 million or €4 million composting plant in Tanzania. It took about 3.5 years to build. Ventilation systems, windrow turning, so it's a combination there. And then that is kind of their and so now this project is now a gold standard CO2 project. So that's the one thing. When it comes to our insect project, right now we're working with a few kind of regulators so companies that basically say, look, we will pay for the certification of your company, specifically on the waste CO2 reduction, and then buy your CO2 from it, and then we'll sell them. So the company we're working with right now is a company in the United States. They sell to like big companies in the United States, corporations and stuff like that. So we've signed a deal with them, and now we're in the process of getting that right, I guess. We haven't done the certification specifically for the insect companies or for the insect project, but we've started that process.
Okay, we have one last question. Is what are the categories of organic waste that are perfect for the black soldier fly?
Great question. So the insect, basically the black soldier fly wants to eat everything that we eat. So it doesn't eat leaves, it doesn't eat tree branches, anything like that, right? So hence why it's important also to have a composting plant as part of it. But basically the higher water content in the food waste makes it more difficult to separate. So we control exactly what comes in to our factories of food waste based on water content. We want to keep the water content low so it's easy for us to separate. Otherwise, you get a very mushy mix. But we need a dry compost and the larvae, and so we can easily separate that. So we are looking for like potatoes or sweet potatoes, so we mix in all the fruit waste from the markets, But then when we get waste from like hotels, like rice, or we're working with the port as well, where the port delivers us like expired flour or expired pasta or something like that. That kind of stuff. So we can control, you know, how much dry stuff we put in with the very, very, very wet organics from the market.
Okay, thank you, Matthew. So there was, okay, so I see we have one more question. So let's take this one more and then we give floor to David. So there's the, what is the, from speaking from Nigeria, what is the influence of government policies on setting up a site? And what do you recommend for a small scale, especially when the market is not really feasible? So after that, we post the questions and we take them later on.
Yeah, so with government, you know, in Kenya, they really pushed allowing for kind of like a standardization of insect feed. You can look at Google it online, and I think that's really helped the industry to say, okay, look, the standardization is very easy, but the reality is that, you know, they're thinking about it in that direction. So stuff like that would help. Also in Tanzania, we work with a municipality at their markets, and it's so much easier when we have the power of the municipalities behind us to say, to go to the market and say, okay, you have all of these cleaners at the market. They need to make sure that there's no plastic or no, like it has to be very, very, very clean waste. And you know, when it's not clean, we're not taking it. So working with the municipality has been very, very good on that, because these are municipal workers that are working at the market. So having that kind of relationship works very, very well. Small scale, the reality is that, like, you know, you need a lot of waste and a lot of equipment to do this on a large scale. So, you know, when you start, it's good to start to try things. And that's how we did. We built a model, and then we were able to raise funding to take that model bigger and bigger. And then now we have this large scale model that we want to cut and paste in different countries. So starting small is probably not going to make money. You're going to need to be able to do around a ton a day of BSF dried in order to actually cover costs based on what we've seen. But it's a way to get interest and to get funding that way. Thanks, guys.
Thank you, Matt. So it seems there's a lot of interest in it, so that's really great. So David, I give floor to you now. I hope your internet is stable enough to share. So you should check you can unmute yourself and click the share screen button, and then start sharing. If you can do this. David, if you're having a problem sharing your screen,
are you getting me?
I can hear you, but I can also share your presentation if it's better.
Yeah, you can. Yeah. So you have my presentation. Can you just go ahead?
Yes. I have your presentation. I'm opening it right now.
Okay.
Let's...
I'm having challenges on my side, so don't worry.
Okay, no problem.
Yeah.
Just a moment. Okay. So, go ahead.
Okay.
Yes, David, go ahead.
I'm David Ngige from Japan Waste Management, whereby we recycle waste by making some products. The project was started as a self-help group in 2007, but was elevated to CBO in 2009 and registered. Therefore, what we shall do, we address the social economy and environmental condition of the vulnerable communities of the slums, while addressing the plight of small-scale farmers through making of organic fertilizer and other recycled products from the waste, whereby the farmers earn their living in a natural way, whereby we assist the fertilizer assists them to improve their soil fertility. And that's and why do we need to recycle biodegradable waste? We need to do it because 1.6 million Kenyans face hunger due to low agricultural productivity. So, therefore, in 2013, the government did a national soil analysis survey showed Kenyan soil is 85% acidic. Therefore, use of natural organic fertilizer on acidic soil will cause a balanced soil nutrients and increased water retention, increased aeration, and increased crop yield. As you can see, how the fertile soil is, you can see how crops are growing. But because of the overuse of the chemical farm inputs, has led our soil to be almost useless. Can you go ahead? Next screen.
Yeah, this slide.
Next slide. Yeah. So the solution here is large waste management cycles waste into useful products, find natural fertilizer for farming and hence clean and the environment. Therefore, one request from the municipality market, as you can see the photo, after composting, we get the organic fertilizer, we sell to the farmers and also to other users, and especially the small scale farmers who do rely on their small scale pieces of land. And after sorting out the organic waste from the inert one, now the compost is ready. The waste placed in the compost pit aligned with the polythene sheets, so that when the scorching sun, the scorching sun cannot be able to replace some nutrients like the evaporation of nitrogen, while the rain cannot cause the leaching of the other micro and macro elements. Therefore, the one fertilizer made from the waste and also mixed up with the garbage enzyme, sucrose food pits for rapid decomposition, whereby those enzymes enhances decomposition because of the sucrose, which is also more needed too in the compost pile by those active bacteria. Can you go ahead? Next slide. Now you can just see here this is the organic. Just go. Can you go back again? Yeah. I've not talked about the pit. Yeah. Now you can just see this is what we call the compost making pit. You can also see those are some of the polythene papers whereby after putting the biodegradable waste inside this pit and covering them, the compost is made through in aerobic, whereby those bacteria they stay in a constant mood, whereby after a period of time, all the pathogens are eliminated through the in aerobic, and also during the mesophilic stage, that's the last stage. All the pathogens like the salmonella are eliminated. After that, you take it out, and then you start sieving. Then after sieving, then you can be able to give to the members, and the remaining one you sell to the community. Then, after composting of at least 4 weeks, you test using farmer's thermometer to identify whether organic waste has fully decomposed. Then the manure is harvested from the compost pit and taken for sieving. After sieving, you put it in a shade, where in a shade or a store, whereby all the other pathogens are eliminated. You package it, you take sample to the government lab for analysis, and then after that, they will be able to tell you which element is lacking and which elements are there. And therefore, in most cases, after using after using your biodegradable waste, then you'll be able to get a good result. Yes, can you go ahead? Now you can see this is now the sieved manure. And you can just see on my left is a sieve. After sieving this one, then you carry it to a store, and then you do what we call the packaging. You go ahead. Then packaging and marketing of the organic fertilizer. After sieving, sample of the manure is taken to the government lab for analysis to identify percentage of the nutrients. Our packaging is done in 50 kilogram, 25 kilogram, 10 kilogram, and 5 kilogram respectively. We do this because the farmers, most of our farmers are small scale farmers. So therefore, there's somebody who has got a small kitchen garden who needs 5 kilogram, 10 kilogram, and you're having somebody who is having a bigger land whereby he needs about 50 kilogram or 25 kilogram. Therefore, we cut across for everyone, for every farmer, for every gardener. And the percentage of nutrients is labeled on the packaging bags. Go ahead. Now you can just see this one. This one is a diazopan fertilizer, premium all-purpose fertilizer. The net weight is 5 kilogram. This one is braided, so that even at the back of this package, there's that component of nutrient. You can just see the percentage of nitrogen, the percentage of calcium, manganese, zinc, iron, and all the other major macro and micro elements. You go ahead. Yes, can you just yeah?
Can you see?
Yeah, it's okay. It's okay now. This is now the business model. After getting the household waste, there is a restaurant waste and market waste. You transfer to a sorting and separation of waste. Then from there, you collect the biodegradable, because now as a transfer, sorting, and separation, that's where you remove the inert material. Those are the plastics and what have you and other material. But now you just carry the biodegradable. Then this biodegradable, you mix with what we call the enzymes, garbage enzymes, which we make ourselves for rapid decomposition. So after mixing, then you put it in a composting pit or a withdraw. I've got so many ways of doing this, but now I'm talking about only the composting pit. Then from that composting pit, after a period of time, it will be okay. Then you remove it for after it have been cured. After that, then you sieve it. After sieving it, you take it to the lab, and then from there you do the packaging, and then you have the product, which is diazopan fertilizer. That's now our business model. Our target market and positioning. Our potential customers are grain and pasture growers, horticulture, crop growers, and gardeners. This is normally done through organizing field and also the marketing. We also do normally through organizing field days, farmers workshops, demonstration, and trade fairs, whereby we carry our product, we sell, and also we give some samples, so that when the customer or the farmer needs it, we just call us, or after using it. So this is some of the part of this is now the positioning of our venture, which is a green enterprise. Again, can you go ahead?
Yes.
Yeah, can you go ahead? Yeah. Now, our market share and the pricing. Currently, our market share is less than 80%. However, we expect as a community to increase of 15% in the next 3 years through marketing campaigns, improved customer relation and hiring competent staffs. But now the COVID has done a lot of havoc to us, because already due to health issues, you cannot collect waste and go and do the composting. So we have stopped a little bit until we get the okay from the authority. Otherwise, this is how we have been planning our things. Even our pricing, our price, we multiply production cost, and then we put a minimum profit, so that to keep the organization running, and also giving our people what we call the dividend from the sales of what we get per year. Now our pricing per unit is 50 kilograms, Kenya shillings, 1,500, which is equivalent to $14.
Shall I go ahead?
Yes. Now, this is what we call the practical community training. On my left, you can just see training the youth and women. Composting is what we do through what we call the withdraw. The withdraw is different from the pit one. This one, you just lay your biodegradable waste onto a flat area, and then you keep on piling. So after piling, what you usually do, use the biodegradable waste, and also we put ash. Ash is for as a catalyst. To get our calcium, we broadcast charcoal dust. And to get the calcium, we use the crushed eggshells, and then we broadcast. And also we also use the molasses. After the diluting, you sprinkle the water of molasses and the garbage enzyme to enhance the decomposition. After doing all that, as you can see here, after doing all this, then you do what we call the casing. Casing is covering the organic with a polythene paper. This polythene paper is a good conductor of the heat, and also it covers our organic from the scorching sun, and also from leaching if it rains, to maintain the nutrient needed. As you can see from the pictures here, you can just see some youth and women coming for our practicals, and you can just see me with an overall trying to train these people, because we need them to learn more, because you know, we want this thing to be replicated in many places, so that our environment will be very clean, and also our farmers will be getting a good returns from their farms. Can you go ahead? Yes. Therefore, I invite you to join me to increase farm productivity through the use of natural organic fertilizer. Let us go natural and make this a reality. Thank you very much. I'm David Ingi from Rajopen Waste Management in Trans Nzoia, Kenya.
Thank you, David, for this nice example of a real solution happening in Kenya. So does anyone have any questions to David? You have Enzo saying thanks to David. Yeah, it was also, I'm really happy that your connection hold, that we heard you very well. So good. Any questions to David?
I don't have a question. I'm expecting questions from the participants. So I'm waiting for their questions.
Okay, so we have a question for Abraham, which is considering the weather, rainy season versus dry season. How is it affecting composting, and how do you deal with it?
I'm not getting you properly.
rainy season versus dry season. You can also see the question in the chat if you didn't hear me well. So
Okay.
composting in rainy season versus in dry season.
Oh, it's not challenging, provided you are having the testing material, because you just do the composting, and then after covering it, there will be no rain. So only that when you are doing the local composting at the field, that's where most of the nutrients go. But with the commercial making of organic fertilizer, there's no problem, because you'll be having almost everything which you need, especially the casing of the one fertilizer, like the one you have seen there. Even if it rains, no rain which will go, you just go inside there, that black polyethylene paper. So your organic will be safe, and all the nutrients needed, they will be there. And very soon I'm going to buy. Very soon I'm looking for a laptop, so that I want to be keep on coming to cyber to look for these services. Otherwise, I might end up. Okay, can you ask another question?
Yeah. Okay. So also, do you have trainings, webinars for interested people?
Well, training. What we do, we have what we call we train people practically, as you have seen there. You come, I train you on how to make it practical, the way you saw those people making the one fertilizer. But if you can just need some material for reading for how to make it, it is easy for me to make, and also so that so that thing can be covered to every part of the country, because all people cannot be able to come out here to see me, and then we do all blah blah. So it's better. I can also do that for free.
Any other questions?
Yes.
Let's see. We have them in the chat. I'm taking it right away.
There's one question. What is the combination in the enzyme?
Exactly.
Yeah. Let me answer. Let me answer this one first. Yeah. The combination of the enzyme is that you ferment all sucrose fruit producing peels, like mango peels, banana peels, orange peels, pawpaw peels. You combine them together, and then you add some part of molasses, so that when they ferment, they have a lot of bacteria. So when you sprinkle those bacteria on the composting material, they will have a rapid decomposition. Okay, instead of 6 months, it will be about 6 weeks. So that's how we call them commercial. Yeah, unlike my net is unstable. Unlike the other one, whereby you just grow the wheat, you just wait for 6 months for them to rot. No, this one is just direct after composting. Then the compost pile will keep on reducing. Then after removing the farmer's thermometer, that's when you will see you see some sign of maturity of the manure through using of the garbage enzyme. So you use the same garbage to treat the same garbage, and also to kill the same pathogen from the same biodegradable waste. It's like using a thief to catch a thief.
Geraldine, can you write your question in the chat, please? I see your hand is up. In the meanwhile, Tumaini is asking how can we receive materials from you? So apart from the presentation, which I will share from today,
the materials.
Yeah, any reading materials.
Yeah, they can. He or she can write to me. Then I'll be able to. I can provide some material. There's no problem. I can just write an email to him or her. Then I just get the whole material, then I send to her.
So Geraldine's question is, how can we preserve waste for farm use for a long duration?
Which one?
How can we preserve waste for farm use for long duration?
How can we preserve waste for farm use for
a long time?
Okay. Now with this, how can you can preserve them using the silage bag, and which is expensive. By using the silage bag, and also using what we call the industrial waste, like molasses, so that you put it in a tightened area, whereby there will be no air inside. You can keep them there. But now it will depend which type of waste do you want to preserve. For example, if you want to preserve the maize stovers, the rice straws, you can use the molasses to preserve them naturally without putting any chemical. As I can just say for even for 2 years. And you can also feed the same maize stovers to the animals to get more milk.
Okay, I hope, Geraldine, your question was answered. So yeah, so then you can lower your hand, or if you want to ask something else, if you want, you can unmute yourself and ask something now.
I think he answered it well.
Okay, so thank you. If we don't have, we had another question before David's presentation, so you can still think of questions and add them in the chat, but there was a question about how does waste to energy fit into this whole paradigm? So I would ask Enzo to reply to that question and explain that a bit.
Yeah, that's a great question. Yeah, well, basically, when it comes to the organics and specific treatment technologies for organics, waste to energy covers anaerobic digestion, because that's a way we process organics. We get a soil improver in the end because we have the digest state. It may be directly land spread on farmlands, but we always recommend to have it post-composted in order to enhance agronomic properties and avoid some of the downsides of using digest state directly. But we have got an organic fertilizer, and we also have got some renewable energy from methane. This is why it should be considered, and typically anaerobic digestion is considered not as waste to energy, so equal to incineration, for instance, but it is considered to be part of organics recycling, because it delivers also a soil improver in the end, and it is part of the organics recycling scheme. We already discussed comprehensively during the previous webinars why incineration doesn't make much sense in Africa. It doesn't make much sense in general, to my opinion, but above all in Africa, because you know that heat is to no use in most sites in Africa. There is a very big percentage of organics, which keeps both the moisture high and the calorific value low. And so the energetic efficiency of incineration is very, very small, which is why we word it rather as waste of energy instead of waste to energy. But if you want also to retrieve some energy while processing the organics properly, you may consider anaerobic digestion. Okay.
Hi, I can share the circular economy butterfly scheme if you want to get maybe a better understanding, just to show you where do they fit in the scheme. So this is sketch that we made. So we have in circular economy, we have the technological materials, which are plastic and metals, which are mined, and then we have the organics, which are on the other side. And then we have, which is, you know, the usual circle, like the linear economy, like we take the things and then in the end, we either incinerate or put them in a landfill. So in circular economy, what we want to create, we want to create the circles in the back. So in the technological cycle, you have these parts. So it's the borrowing, the repairing, the reusing, refurbishing, and recycling. And then on the biological side, we have, the donating the food, which was like Enzo said, feed the people. Then we have recovery, making the biochemicals. And then we have, the biorecovery, the biogas, biofuel, compost. So this all fits into the organic side, whereas incineration is here on the bottom. So that's the difference between them, because biogas still puts it back into the cycle, whereas incineration basically just destroys it. So that's the difference between them. Okay, I can also share this slide with you if you want. What we have here. Oh yeah, so Abraham is asking David's WhatsApp number. You're also in the WhatsApp chat of our training, so you can also get it from there. Do we have any more questions or remarks or other thoughts or ideas of this super interesting topic that I'm hoping you all got more knowledge of? I see that anyways, probably you have more details to discuss in person to person, so you can already get deeper into that topic then. But yeah, in that terms, if you don't have any more questions, you will get the presentations later on. We will share the recording. You can have one-to-one discussions with each other. I see Enzo wants to still say something, so go ahead.
Yeah, very, very quickly. I also put in the chat the web link to the SWIA policy paper on choosing between composting and aerobic digestion and the way to do it right. Okay, so you may go there and download it yourself. But anyway, we will send a PDF paper on that alongside our own slides.
Mm-hmm. Abraham, you also have a raised hand. Go ahead. I think you're muted on your computer because we can't hear you. Maybe it's your computer muted because, or your microphone is working because I cannot hear you.
Okay, you hear me now?
Yeah,
okay.
Perfect.
Thank you to all our presenters for the amazing ideas and achievements and activities in your country. Since the beginning of this training, like I told one or two friends, I already started with plastic, and since then, the community that we're in, we've collected more than 50 to 100,000 pieces of sachet of plastic. But like we all learn, the biodegradable is something that is the low-hanging fruit. But like still anticipating, like, how do I start it? And maybe a one-on-one conversation with anybody into that will really, really help me, because the community actually yelling for us to do this. Yeah.
That's really nice to hear. One thing which I wanted to maybe we can make a group photo. So if you can turn on your cameras and if you're agreed to being photographed, so then I would take a screenshot of us.
Okay.
So where we have this, so we have people here, just waiting for a moment. Everybody's cameras coming in. Okay, waiting for the cameras. Okay, let's go the first try. Oh, okay, few more pictures coming in. Okay, smile. Okay, I'm gonna make one more. Okay, just a moment. Okay, so 1, 2, 3, smile. Thank you. Okay. Okay, so yeah. Any last questions that you still want to ask? or you're all inspired and ready to dig deeper even more into biowaste and composting? Yeah, you all look very happy, so I'm convinced that you take this further. So thank you, Enzo, Matthew, David, very much for your presentations and your insight and knowledge into the topic. And yeah, feel free to connect with each other. The context will be shared and you will get from the presentations. So yeah, thanks for participating.